on the green fence. On the green fence.
Now, that is something that would keep me up all night. And I'm actually really lucky because I live in a region where mosquitoes, they're not really that dangerous. Well, not yet, anyway, because global heating is changing the game a bit and all sorts of nasty tropical diseases are beginning to pop up in more temperate regions, also here in Europe and in the US. Hello everyone, I'm Neil King, your On the Green Fence host, and this is the third episode of our series on climate change and health.
It's very dangerous because then it can transmit the virus from one to another person. And that's really different from our native mosquito species.
That's biologist Artur Jöst, who's also one of Germany's top mosquito hunters. We'll get to him and his organisation in a bit. But first, just a little bit more about mosquitoes and vector-borne diseases. Now, scientists, they've been saying for some time now that rising global temperatures can lengthen the season and geographic range of disease-carrying insects, or so-called vectors, such as mosquitoes or ticks. And this is simply because vectors, which are cold-blooded animals, they do better in a warmer world. But yeah, just how problematic is this for us and what can we do about it? That's what I'll be looking at in this episode. And we need some stats just to illustrate how big a problem vector-borne diseases are already. More than 80% of the world's population is at risk from at least one vector-borne disease. Malaria alone accounts for around 429,000 deaths annually, while close to 100 million fall ill with dengue every year. Now, these and other vector-borne diseases account for 17% of the global burden of all infectious diseases. And the world's poor are bearing the brunt of this. Now, there are many types of vectors, but mosquitoes are by far the most dangerous. Over 700 million contract a mosquito-borne disease every year, and over 1 million die as a result. This means that mosquitoes kill more humans than any other creature in the world. Now, scientists, they predict that climate change will expose half of the world's population to disease-spreading mosquitoes by 2050. Now, there are about 3,000 mosquito species worldwide, and for this episode I decided to pick one particularly aggressive and invasive species, the Aedes albopictus, or Asian tiger mosquito, which can transmit several very nasty tropical diseases, including chikungunya fever, dengue fever and Zika. Now, this mosquito started out in Southeast Asia, but in the last 30 years it has invaded many countries around the world, including various regions in the Americas and the Mediterranean. And in 2007, it was detected here in Germany for the very first time, just a couple of hours further south from me here, as a matter of fact. But just how did it get here, and what does this mean for us, in future? So high time to bring in biologist Artur Jöst. He's an expert on the Asian tiger mosquito, and he's also with a communal action group based in Speyer, which is called KABS, and which monitors and controls mosquito populations in southwest Germany. He knows all about this nasty little mosquito, and he also seems to have a kind of love-hate relationship with it.
Yes, it's very aggressive and it's very assertive. It's able to transmit more than 20 different viruses to humans. It is able to displace native mosquito species. It's also very adaptable concerning the choice of suitable breeding sites. Aedes albopictus uses all kinds of containers filled with water. And so it is possible for them, if the conditions, the temperature, etc., are right, to reproduce more or less everywhere. So Aedes albopictus has the ability to produce diapause eggs, which is very important for our region in Germany, because those diapause eggs, the embryo in the eggs, are able to survive winter. In America as well, and in Germany, this ability was very important to build up stable populations.
That means that once they're there, they stay, because the winter doesn't kill them off.
The winter doesn't kill them off. if the conditions are good, and that means the summer temperatures should be high, then the species is able to build up some generations. We know in Germany, between 4 and 6 generations are possible. And then the last females, they produce those special overwintering eggs, those diaporsing eggs, and almost, let's say, enough 40, 60, 70% of the embryos are able to survive our winter and start with the new population right in April, for example. So if the conditions are good and the mosquito has been transported to this place, then it's not so easy to get rid of them.
The other thing that I also read about this mosquito is, just for us, sitting out there, normally you hear mosquitoes and they normally come, when it's duskish or when it's dark at night. But this mosquito, it's day active, right? You can't hear it. It doesn't really make a noise, I read. And it's also very nervous, so that if it attacks you and starts drawing blood and you try and chase it away, it'll immediately go to the next host. So
yes,
it's actually perfectly suited to spread disease fast if it's infected, right?
Right. And that's the problem. You said this high vector capacity, as we call it, it bites one and then flies to the next one. It's very dangerous because then it can transmit the virus from one to another person. And that's really different from our native mosquito species, which normally bites one. And if it's enough, then the mosquito flies in a hedge, for example, and digests there. But Aedes albopictus is much more aggressive, and that makes it really a nuisance pest and also a dangerous animal.
You're a biologist. If you were to describe this mosquito, how would I recognize it? What does it look like?
It's a very beautiful mosquito. It is black and silver-white colored. It's very attractive. If you see this mosquito, it's quite small. Most of the native mosquitoes are larger than the tiger mosquito.
I also read that the average lifespan of mosquitoes is 3 to 4 weeks, and that they can fly at a speed of just over 1 mile per hour. It said something like 1 to 3 kilometers per hour. How did this Asian tiger mosquito get to Germany? It didn't fly here, did it?
Right. Tiger mosquitoes are quite lazy, They don't like to fly around very much. We talk about just a few hundred meters per generation. It's totally different from the native mosquito species, from the floodwater mosquitoes, for example, Aedes vexans, which are able to spread, let's say, 10, 15 kilometers during their lifespan. So this is totally different. And the passive distribution is much more important for the spread of Aedes albopictus than the active one. That means passive distribution by vehicles like cars, trucks, ferries, or caravans. The tiger mosquito is so aggressive that they follow us because they want to bite us. And this is how they get into the cabin, for example, of a truck driver. And then the mosquito is transported from A to B as stowaway in our vehicles, This spread through the global trade and the rising mobility of us humans is most important for the distribution of the Asian tiger mosquito.
Okay, so globalization, it also plays its part in spreading vector-borne diseases.
Yes, it's known that it's the eggs of the Asian tiger mosquitoes are transported with the trade of discarded tire globally, and also the flower trade seems to be a very important distribution source for this mosquito.
Okay, so the Asian tiger mosquito is here in Germany now. At what point do you speak of a mosquito plague? When does it become a problem in terms of figures? Is there a number or a threshold?
Even a few tiger mosquitoes can be so aggressive that you don't want to stay on this place. So the threshold is very low concerning the tiger mosquitoes. And if we detect one tiger mosquito in one of our member communities, then immediately a targeted monitoring and vector control program is initiated. So for us, the threshold is 1. And then we have to look, is there a population or was it just a single specimen, for example? But they can reproduce within, let's say, 20 days completely. So during summer month, when the temperatures are really high, they are able to fulfill the generation cycle within 20 days. The reproduction is very high. During August and September are the highest population densities, which causes most nuisances.
Can you perhaps, mathematically speaking, if you say, that the alarm bells are already raised with one, that you already, spring into action with one, I mean, how fast does this snowball? How fast does one mosquito or two mosquitoes become, I don't know, do you have any stats on?
Okay, so this depends on the question, if the population remains uncontrolled. If this is the fact and the temperatures are high, then you have a high population density. And then, of course, the probability of distribution via vehicles or what else is very high. And then you have spreading of the mosquito, let's say, which could be within a few weeks or a month, that a whole village could be populated by this species.
I mean, how fast are they spreading?
It's the Upper Rhine Valley, which is, of course, the most favorable region in Germany for exotic species, because we have those high summer temperatures. I think climate change, and in particular the above average warm summer month of the last 10 years, have led to this successful establishment of the tiger mosquito in southwest Germany. And if this trend continues, then the Asian tiger mosquito will continue to spread in Germany, even in areas that are now not so suitable. But this will play an important role when the people are able to travel more frequently than now and bring the viruses, for example, then back from the endemic areas back to their hometown. If then the temperatures are high here in Germany, then of course there is the risk that the virus can multiply inside the mosquito, and even then autochthonous cases are possible.
So just to get this straight, this does mean that these viruses like dengue fever and so forth, it always requires a human host for this to spread in the first place. It's not that the mosquitoes are born with these viruses. They have to get it off people and then they transmit it.
That's true. It's possible that the female can transmit the virus to the eggs, but only in the tropics. It depends on the temperature. This is not possible in Germany or in the middle of Europe.
Not yet.
Not yet, yes. Not yet, you're right. Okay. So at the moment, the mosquito has to infect itself from a human. Yes.
Okay, so now, I mean, these species, like the Asian tiger mosquito, I mean, what does the arrival of this, it's a very invasive species, what does it mean for the native mosquito populations? How great is the risk that, one day, or maybe it's already happening, that native mosquitoes will also transmit new diseases?
So first of all, our foreign colleagues report that Aedes albopictus is able to displace native mosquito species. We cannot confirm this yet, but maybe this is just a matter of time.
How does it do that? How does a mosquito displace another mosquito?
The tiger mosquito larvae are adapted to very small vessels, because they're tree-hole breeder in original. And they are also able to stand higher temperatures as native mosquitoes. And so they can cope with high density of larvae in a very small vessel. They can cope with better than the native ones, for example. And they eat all the time, and maybe they eat all the food in the vessel, and the natives, they starve, for example. That was the one question. The other question is, I think a very important point is that we have to know that not every mosquito can transmit everything at any time, everywhere. And that means that the ability to transmit certain viruses is the result of a very long adaptation process between host and pathogen. That means it will not happen that our native floodwater mosquitoes like Aedes vexans, for example, are suddenly able to transmit dengue or chikungunya virus. But what is true is that the common house mosquito, Culex pipiens, is able to transmit the West Nile virus. But this is not a new adaptation. This ability exists for a long time. Although there are no cases known in the south of Germany, since 2018-19, the first autochthonous cases have been observed in the eastern part of Germany. And this is something indeed what should be taken seriously.
Okay, Artur, I think we've established, just how problematic this mosquito can be, the Asian tiger mosquito, or the Aedes albopictus, to use the Latin term. What can be done about these mosquitoes? What is your organization also doing to, address this potential? Well, it's a threat, right? It is a threat.
It is a threat, of course. If an Asian tiger mosquito is detected in a KABS member municipality, then a targeted monitoring and vector control program is initiated. In detail, from April to October, our staff go door to door, treating every potential breeding site with BTI to control the larvae. BTI is Bacillus thuringiensis israelensis, which is a protein complex. This is our active agent.
Okay,
we use.
That's like a larvicide, is it?
It is a natural larvicide, yes. Mm-hmm. The proteins are first ingested by the larvae with food in the water. Mm-hmm. And finally, they will burst. And this is, of course, the end of the larvae. All other organisms, like other insects, mammals, plants, even humans, are not harmed in any way.
Mm-hmm. So that sounds like a very sophisticated, selective bioweapon.
Yes, that's true. And it's a natural product, Mm-hmm. This is not let's say, a chemical insecticide, which generally has a broad effect.
There is also another option that I read about that you have. If you, say you can't get into a certain area, you can also put up traps to draw the mosquitoes to you, right? Scented traps.
Yes, it's also a method to reduce the population density with those traps. It works quite good as an additional tool, but it's not efficient to eliminate the whole population. This is not possible with those traps.
The way you tackle the issue with, the biological larvicide and also with the traps, etc., it's a very natural way of doing it. If we look at the root cause of this, how these viruses are transmitted, I read that scientists are also working on a vaccine that could work, against all pathogens that are transmitted by mosquitoes via their saliva. How promising is this research? That would be a game changer, right?
I think we are far from such a solution because there are so many changes year by year concerning the pathogens, for example, and it's almost impossible to get one vaccine against dengue because we have 4 sub-viruses from dengue. It would be very difficult to create one for all. But I think for the next future, we have to use our old weapons to eliminate those populations or to reduce the populations. Yes.
I also read that the first genetically modified mosquitoes were released in the United States. The aim was to suppress the populations of mosquitoes that carry diseases such as Zika or yellow fever. What is your take on genetically modified mosquitoes? Is that a good idea?
It could be a good idea. I'm quite open to all tools which help us to reduce the populations and the population density. I think it depends on the special case. In Germany, we won't get any permission to do something like that. We are able to release sterile males. That's not a problem. We use this in former years as an additional tool to reduce the population density. That worked quite well. But any other vector-based methods, we don't get any permission for that.
As you just said, genetically modified, that is something immediately, it's like a red flag in Germany, isn't it? Anything relating to genetically modified food, for instance, or genetically modifying animals is like the alarm bells go off and it's like, oh no, that's way too risky. We're not going to mess around with nature.
Yes, it's a very emotional discussion, Even if the facts are others, it's very difficult to convince the people that there could be a hope in those techniques, it could be good, it could be positive for the effect, but it's so emotional, so it's very, very difficult to discuss with the people.
There was also, Artur, I came across something which I just thought was staggering. There's a Canadian historian called Timothy Weingard, and he wrote a book on mosquitoes and their role in human history. Ever since we've been around as humans on this planet. And he was quoting, scientists, demographic data and all that. And he was saying that of the 108 billion human beings that have ever lived on this planet, mosquito-borne diseases have killed close to half in human history. So it was like 52 billion people, the majority of them young children, who were killed by mosquito-borne diseases. Mosquitoes cause more suffering than any other organism. And still today, over 1 million people worldwide die from mosquito-borne diseases every year. Now, this question is for you also as a biologist. Given that climate change is set to expose half the world's population to disease-spreading mosquitoes by 2050, so it's going to get more, wouldn't humans be better off without mosquitoes altogether? How problematic would it be if we took mosquitoes out of the food chain?
I think mosquitoes in general are not an essential food basis for any other animal species. They are eaten occasionally as bycatch, for example, but that is only a bycatch. No species need mosquito as an essential food. So I think mosquitoes have the right to be on this earth, of course. We shouldn't ask what is the benefit of one species. They are here, they are longer than humans on this earth, and I think it's okay to reduce them. But as you said, mosquitoes have a place in this world, and so I don't want to if I could, I wouldn't eliminate them completely.
I understand where you're coming from. I mean, I must admit myself, mosquitoes, or ticks for that matter, those are sort of the few animals that I don't feel guilty killing at all. I don't feel any remorse. If anything, it's satisfaction when I have a mosquito in the house and I manage to find it and get rid of it. It makes me feel better, as a matter of fact. But the ethical question, of course, they've been here longer than us, as you said. They have a right to be here, just like we do. But I mean, if we're looking at the threat level, also, I mean, I live down the Rhine just a couple of hours from you, a bit further north, so it's a bit cooler. How long have I got until Asian tiger mosquitoes are zooming in and out of my house? And how worried should I be, or what should I be doing, in preparation for this?
People should be attentive and report suspicious mosquitoes to the local authorities, for example, or to us. And therefore, it would be good if the people slay the mosquitoes gently. I know this is difficult, but they should slay them gently and take then pictures from different positions of the mosquitoes for evidence. So that's something everybody should do.
Citizen science, that is.
That is citizen science, yes. That's public awareness raising campaigns, that the people realize, this could be a dangerous mosquito, for example, and then they should know what to do.
I also read on your website that it's good to catch them in a jar, if possible, then put them in the freezer overnight.
Yes.
and then you send them in by mail to the authorities. And is it still alive then when it's frozen, or is it dead?
No, it's not alive, but you can see all the features which are important under the microscope. For example, you can detect, is it really a tiger mosquito or is another mosquito who is similar shape, for example.
Okay.
And last year we got about 2,000 emails from citizens who sent us pictures, for example. And this is really good to detect new populations when they are still at a low level. So this is one possibility,
Yeah. I'll certainly bear that in mind because I've got plenty of empty jam jars at home. So the next mosquito that I see flying around, with striped legs, black and white, I'll pop it in that jam jar and in the freezer, and the next day it's in the post to you.
You can send it to me, yes. And you will get a feedback.
And then, of course, there's also, once you've got them in the house, there is also mosquito repellent, right? So, I incidentally, I saw that the global mosquito repellent market was valued at more than $4 billion in 2020. Yeah. It's a growth market. It's expected to grow by 5.6% over the next 5 years. Do repellents really work against the Asian tiger mosquito?
repellents work if they have a special ingredient. And a very good ingredient is, for example, DEET. And if the percentage of this ingredient is about 40-50%, and then you have a good impact for at least 5 to 6 hours or something like that.
Artur, thank you very much for your time and giving
Thank
us
you.
all your expertise on the Asian tiger mosquito. I'll be looking out for it. I do appreciate your time. Danke.
Tschüss.
Ciao.
Ciao.
Okay, so time for my main takeaways. First off, I really don't like the sound of the Asian tiger mosquito one bit. Admittedly, they don't make any sound, according to Artur, which in itself I find creepy. But the bad news is that it's probably just a question of time before I'll be seeing tiger mosquitoes in my home, because they will spread with global heating. There also was this number that stuck with me. Half the world's population will be exposed to mosquito-borne diseases by 2050 if we fail to tackle global heating. I thought that was rather striking. The good news is that vector-borne disease can be prevented with rather simple and also eco-friendly measures, as Artur lined out. We don't necessarily need chemical pesticides for this. I also thought it was very interesting that Artur, as a biologist, was rather open to GM solutions to control populations, something that's very controversial here in Germany. I think he does really stick out there. But no matter how we go about it, prevention is the way forward. We need to monitor and control the problematic mosquito populations. Having said that, we can only control them if we know about them. And as Artur said, right now here in Germany, we are still kind of dependent on, citizen science, so people being vigilant and sending in samples, etc. So, we certainly need more of these early warning systems if we don't want things to get out of hand. Now, of course, this kind of monitoring and prevention costs money, but doing nothing will likely cost more than the cure. Vector-borne diseases can be quite a burden to the economy and certainly also the healthcare system, also with people dropping out of work, etc. It's difficult to put a price tag on this for all vector-borne diseases. I did do some digging, and I found a figure by the WHO, which has estimated that the aggregated global cost of dengue, which is transmitted by the Asian tiger mosquito, they put that at around $9 billion. And that's just one disease. Now, just for context, in the US alone, there are currently 14 vector-borne diseases that are considered a national public health concern. So, we're talking big bucks here. But the bottom line remains that vectors like warmer temperatures. So actually, the single most effective measure to stop the spread globally is to reduce our greenhouse gas emissions and keep a lid on global heating. It seems to be the cure for so many things, doing this series, as I've discovered. Anyway, that's my 2 cents for now. Please do let me know what you think about all this. Are you exposed to dangerous vectors where you live, and how are you dealing with that threat? You can email me at onthegreenfence@dw.com. In the next episode of our Health and Climate series, I'll be taking a closer look at the spread of allergies amid global heating. And in the meantime, you can always listen back to this and other episodes of On the Green Fence wherever you get your podcasts. Time to wrap things up here, but before I go, I'd like to thank my producer and colleague Natalie Muller and my sound engineer Gerd Georgi. And of course, a big thank you to all of you out there for taking the time and listening to On the Green Fence. My name is Neil King. Take it easy and take care.